Good evening everyone. I am Dr. I. Veeranjanailu, coordinator of Aditya Learning Academy, and it is my pleasure to welcome you all to the online lecture series on research scope in emerging areas of civil engineering. This event is organized by ALA in association with the Department of Civil Engineering at Aditya University, Surampalem. Let me start by giving a small introduction to our university. Aditya University is a place where students grow not just academically but also personally. Education here is more than just earning a degree. It is about discovering students' strength and preparing for a bright future. With students from over 20 countries, our campus is a vibrant, diverse and inclusive community that fosters innovation and collaboration. This global environment helps students develop the skills they need to succeed anywhere in the globe. At Aditya University, we aim to prepare the students make a positive impact wherever you go. Now I would like to introduce our Aditya Learning Academy, ALA. As a center for teaching and learning at Aditya University, ALA is dedicated to advancing education through specialized certification courses. So far, we have successfully completed 3 online certification courses, such as the first one is Machine Learning and Gen AI. It is conducted from August 5th to 16th, 2024. Second one is Data Visualization with Power BI and Tableau, conducted from September 23rd to October 4th, 2024. AI Tools conducted from December 23rd to 28th, 2024. In addition, Aditya Learning Academy has also conducted an online lecture series on emerging trends of research in electrical engineering. It is held from November 6th to 16th, 2024. All of these programs received great participation, and it is clear there is a strong interest in learning these valuable skills. Today we are starting another exciting program focused on research scope in emerging areas of civil engineering. A total of 269 participants have registered for this program, which will run for the next 10 days. During this time, you will have the opportunity to engage with expert resource persons to explore topics such as the importance of sustainable construction materials, research and applications of fiber reinforced concrete composite materials, emerging studies on functionally graded materials, ground improvement techniques, fluvial hydrodynamics around parallel bridge piers, AI applications in concrete technology, green materials for construction, the effects of shear reinforcements, metal contaminated soils and their remediation. This program is designed to help you understand these areas better and gain skills to advance your professional and personal growth. Finally, I would like to invite today's distinguished resource person, Dr. B. Ram Mohan Reddy sir, HOD of the Department of Civil Engineering, to begin the session. Thank you all, and I wish you a productive and great learning experience.
Hello everyone, I welcome all the participants to the lecture series on research scope in emerging areas of civil engineering. It is organizing by Aditya Learning Academy at Aditya University in association with Department of Civil Engineering. So once again I welcome all the participants to day 1 lecture. Day 1 lecture is on geopolymer concrete. So today I am going to cover the overview of geopolymer concrete. And coming to myself, I am Dr. Ram Mohan Reddy, Assistant Professor in the Department of Civil Engineering at Aditya University. And coming to geopolymer concrete we can broken into 2 parts. One is geo, it indicates earth. The materials which were drawn from the industrial byproducts are natural minerals which is used as a aluminosilicate materials are primary binders in geopolymer concrete. That's what we are calling it as the geo. And second term indicates the polymer It's like a polymer substance made up of large molecules of repeating structural units. Typically, it's like a covalent chemical bonds. In the geopolymer concrete, the term refers a chemical bonding that occurs between activated aluminosilicate materials like industrial byproducts to form a solid structure like a stone. That's what together we are calling it as a geopolymer concrete. And these are the contents we are going to discuss in this presentation on geopolymer concrete. Coming to need of geopolymer concrete, cement is one of the most frequently used construction material, and India's cement production is increased from 230 million tons in 2011-12 to 380 million tons in 23-24. So the production of cement is increased drastically from 230 million tons in 2012 to 380 million tons. So, and India is the second largest cement producers, and production of cement will liberate carbon dioxide into atmosphere. And if you can see here, 1 ton cement production emits 1 ton, means equal quantities of carbon dioxide into atmosphere. So that's what the entire cement industry is looking for, eco-friendly alternative materials to the cement. And also cement production requires lot of raw material and also external energy, so that the industry is looking for alternative cementitious material. And if you will see this flow chart, it indicates in how many stages the carbon dioxide is liberating into atmosphere. You can see in the calcination, the rotorical, we need to give the external energy. At that time, the carbon dioxide is releasing into atmosphere. Second, to grinding the clinker, also external energy is required. So this is at this stage also carbon dioxide is releasing into atmosphere. In these two stages put together, around 1 ton production of cement liberates equal quantities of carbon dioxide into atmosphere. Because of these reasons, these environmental concerns, the cement industry is looking for alternative cementitious material or alternative binding material which is required to produce the concrete. So most of the researchers are suggested geopolymer is one of that alternative material to conventional concrete. And also as a civil engineer, we should have concern towards a global warming. We need to mitigate, and geopolymer will be that alternative substance for a conventional to produce, to reduce the global warming. And coming to the introduction of to geopolymer concrete is an innovative eco-friendly construction material, and it replaces cement in the concrete. Means in some of the concretes like PPC concrete or slag concrete, we can able to replace a part of cement in the production of concrete. But in the geopolymer, we can replace the binder like a cement, 100% we can replace with either industrial byproduct, industrial waste material. And also the hydration process that occur in the Portland cement, we know that it require water for hydration process. But in the geopolymer concrete, the hydration process is not there, because in geopolymer concrete, geopolymerization will plays a major role in the attainment of strength. So that's what the water curing is not required for geopolymer concrete. So these are the reasons why the industry is looking for the geopolymer concrete. And if you will see this diagram, this is ash pond. The image is taken at one of the NTPC, National Thermal Power Corporation, where you can able to see the fly ash is dumping on the open land, and it will create so many environmental issues, like it will pollute the ground, it will pollute the surrounding vegetation, it will pollute the groundwater, it will pollute the water on the surface, it will pollute the air. So that utilization of fly ash in a sustainable way, geopolymer concrete is the solution for it. And what the literature is saying, so Professor Joseph David Ertz is introduced this geopolymer concrete in 1970s, and according to him, what published a paper like a geopolymer cement is the title, and different types of geopolymer cements he used with the different industrial byproducts, and he concluded that fly ash based geopolymer cements will reduce CO2 emission up to 90%, because we are not using ordinary Portland cement here, we are using fly ash as a replacement to cement and producing the concrete, so that we can able to control the emissions of carbon dioxide into atmosphere. And in another study on mechanical properties of fly ash based geopolymer concrete at oven and ambient curing, and he concluded that 100% fly ash based geopolymer samples shown better properties under elevated temperature. Means most of the researchers are presenting that 100% fly ash based geopolymer concrete will give better results at an elevated temperature at 40 to 80 degrees centigrade. And in another study, long term and short term properties of geopolymer concrete is carried, and he concluded higher concentrations of sodium hydroxide solution resulted in high strength and durability as compared to OPC. So that the concentration of NaOH will also plays a major role in the attainment of enhanced strength and also good durability properties to geopolymer concrete. Like this, many researchers has elevated geopolymer concrete is an effective alternative to the conventional concrete. So similarly, we can see in this slide influence of binder. What are the different binders will influence on the strength and durability properties of the geopolymer concrete. And this will present about the alkaline solution, because alkaline solution is one of the important factor where depending upon this the activation of industrial byproducts will plays a role. So that what kind of alkaline solution we are chosen here, either it may be sodium based or potassium based, or else we are chosen molarity of NaOH solution or sodium silicate to sodium hydroxide ratio. Based upon all these parameters also we can able to analyze the strength and durability properties of the geopolymer concrete. And how all these factors will affect on the microstructural studies will be presented by various authors, and how the formation of Nash and Cash gel, okay, all these things we will see in the coming slides also. And what are the durability properties? So not only a short term strength or properties to the geopolymer concrete, most of the studies are elevated geothermal concrete will produce better durability properties as compared to the conventional concrete. They are presented like RCPT results, and they concluded RCPT results are good when the fly ash is combined with GGBS in the production of geopolymer concrete. Like that, many authors are explained clearly the durability properties of geopolymer concrete is much better compared to the conventional concrete. So similarly, what are the practical applications? So in the coming slides we will also see the same. And if you will see the visualization of where the research is going on geopolymer concrete, for example, this visualization of the country will present which country is playing a major role towards the research is going on geopolymer concrete. If you can see, predominantly India is occupied the first place where huge research work is going on in India, and next Australia, then China, Malaysia, United States. In these countries the many research activities are going on, particularly on the geopolymer concrete. And similarly, if you will see this visualization through the keyword, means what kind of materials which we are using in the production of geopolymer concrete will seen from this. You can see inorganic polymers, fly ash, geopolymer, compressive strength. So wherever small dot is indicating where more research scope is there, because most of the authors are not touched these small dots because only less research work is only done, so that we can select these areas where small dot is there and we can elevate the further research on the geopolymer concrete by selecting these points. The applications, so based upon SI and AL ratio, we can also say what kind of applications we can use the geopolymer concrete. So SI by AL ratio, what one indicates to all these things, I will present in the next slide, coming slide. And not only in one or two applications, geopolymer can be useful in all the applications where you can see the construction of structures, durable constructions, lightweight concrete applications and pavements. Because in the pavements we are observing in many areas water curing, we are placing the major issue. So that to avoid that, geopolymer will place a major role here, because geopolymer doesn't require any kind of water curing. And 3D concrete printing as well as high temperature resistance, the places where high temperature resistance is required, at those places also we can use the geopolymer concrete. And these are some of the applications. And the constructions which were done using the geopolymer concrete in Australia, so Queensland Global Change Institute, it's an university, they constructed by using geopolymer concrete. It's world first the construction which is done by using the geopolymer concrete. And coming to the runway, so Brisbane West Wellcamp Airport is also constructed. It is also there in Australia, constructed by using geopolymer concrete. And geopolymer applications, not only for runway and entrance bridge, and many other applications also they used. And coming to in India, Delhi Metro project, geopolymer concrete is used, and Mumbai roadways geopolymer concrete is used. And so this Angarwadi building, the geopolymer concrete is used to construct this Angarwadi building. And most of the researchers are confusing the difference between the alkali activated concrete and geopolymer concrete. So David Oates clearly explained the geopolymer concrete is different and alkali activated concrete is totally different, because the binders which we will use in the alkali activated concrete is industrial byproducts such as fly ash, slag, metakaolin we will use as a binders. But coming to geopolymer concrete, we will use aluminosilicate materials, the materials which are rich in aluminosilicate, those we are going to use. And the activator solutions are same, either sodium based solutions like sodium silicate, sodium hydroxide, or potassium based solution, potassium silicate and potassium hydroxide we will use as a activator solution. Similarly in GPC also we are going to use. And in the activation process, these key points will place a major role. Dissolution of silica and alumina from the industrial byproducts which are choosing will place a major role and will produce cementitious matrix, that is through polymerization and gelation. But here same we are calling it as a 3-dimensional aluminosilicate network. So simply we are calling it as a geopolymerization, and it will produce a rigid amorphous to semi-crystalline network. And chemical composition and microstructure, if you will see the difference between AAC and GPC, where cash and ash gels will form, where cash is nothing but calcium silicate hydrate, where if you are going to use slag or calcium rich materials as a binders, then clash gel will produce, and which will be the we can identify through microstructure. And ash, where we are going to use silica and alumina rich materials, where ash will be produced. Similarly here we are calling, in the microstructure we are going to analyze the geopolymer gel network that is formed from alumina and silica bonds. That is the major difference in the microstructure of geopolymer and also alkali activated concrete. Coming to the difference between ordinary Portland cement and geopolymer cement. So this is the major point where everyone should know what is the difference. The various points I have presented here. For example, binding material. In geopolymer concrete, alkali activated aluminosilicates like fly ash, slag or industrial byproducts we are going to use as a binding material. In conventional concrete we know ordinary Portland cement is the binder. And primary ingredients which we will use in geopolymer concrete is industrial byproducts such as fly ash, ground granulated blast furnace slag, alkali activators such as sodium based or potassium based materials. And in the conventional concrete, cement, natural aggregates or artificial aggregates, water and admixtures we are going to use for better workability. And CO2 emissions, in major advantage why people are looking for the geopolymer concrete is it's have environmental advantage like carbon dioxide the significantly lower due to absence of cement, means the carbon dioxide liberation is less as compared to the ordinary Portland cement. And curing method, generally in the geopolymer concrete, curing will play a major role in attaining the strength, that we can go for either ambient temperature or elevated temperature based upon the environmental conditions, the place where we are going to produce the geopolymer concrete. At the same time, the binders which we are using will also we can decide whether we are going for ambient curing or else elevated temperature curing. But OPC, everyone knows that we need to go for water curing in most of the times. And strength development in geopolymer concrete, the strength will be rapidly, and the early strength will be attained at heat curing. And strength development is gradual, and temperature is also dependent for the conventional concrete. And coming to the durability, as compared to conventional concrete, geopolymer concrete is better durable for chemical resistance and chloride penetration and acid exposure. At these solutions, so geopolymer concrete will produce better durability. And coming to the workability properties, there are many factors which will include in the geopolymer concrete to increase or decrease the workability properties. But here in the conventional concrete, so we can adjust accordingly by adding admixtures or additional water content to the conventional concrete. And as compared to conventional concrete, geopolymer concrete is more sustainable because we are using industrial waste materials in the production of the concrete. And the cost is also one of the important factor where people are looking for. Initial cost of the geopolymer concrete is little bit high because the activator solutions we need to purchase, but initial cost of the conventional concrete is less. But compared to the conventional concrete, geopolymer concrete is more durable, so that in the long run we can able to reduce the cost of the maintenance. And coming to the standards, geopolymer concrete, till now there is no proper Indian standard guidelines for the mixed design or some other properties of the geopolymer concrete, but we are all known. So we have 10262 IS 10262 for mixed design of the conventional concrete. And the importance and applications of geopolymer concrete, if you will see, in 1970s itself, the geopolymer term is introduced by Joseph David Oates, and he presented that utilization of industrial byproducts will utilizes the industrial byproducts so that the carbon dioxide emissions will be reduced, which will be produced at the time of cement production, and it is an environment friendly material, and entire cement industry and construction industry is looking for such kind of materials. And also, if you will see, by using geopolymer concrete we can avoid of bleeding and segregation, and low shrinkage, low permeability, not required any kind of water curing, and strength as required, means based how much strength we need, based upon that we will choose the proportions of industrial byproducts and also alkaline solution properties, and it is highly durable as compared to the conventional concrete. And also coming to the environmental concerns, it will reduce the industrial waste, because in many industries the waste is dumping on the open lands, it is creating many environmental issues that can be avoided by utilizing those waste in the production of concrete. And it's an eco-friendly and sustainable, it reduces carbon dioxide emissions, and through that global warming will be reduced, which is caused because of cement production. And these are the materials which we are used in the production of geopolymer concrete, as I said in the early slides. So it's either sodium based or else potassium based, sodium silicate or sodium hydroxide, potassium silicate or potassium hydroxide we can use. In many researches are presented, sodium based activators are used, alkaline solutions are used because of the economic point of view, and these are the aluminum silicate materials which will be used as a primary material in the like a binder in the production of geopolymer concrete. So now we are going to see each and every industrial byproduct. For example, fly ash, we all know fly ash is a byproduct which will be produced in the production of coal based thermal power stations, and it is rich in silica and also alumina, so that it is more suitable in the production of geopolymer concrete. And if you will see, there are two classes of fly ash, class F and class C, and class F fly ash is requires an activator to become a cementitious material. So that's what we are using here, the activator. And class C, if you will use, and we can also call class F fly ash is a low calcium fly ash. And coming to another type, class C fly ash is a self cementing properties because it is having more calcium content, and it is an pozzolanic material. By utilizing fly ash in the production of concrete will lowering the carbon dioxide emissions into atmosphere and making the concrete an eco-friendly alternative to the conventional concrete. And you can see this graph indicates the fly ash generation and utilization in the years. If you will see, we are able to, in 2023, if you will see, you can be able to utilize only 65 to 70% of the fly ash in various applications. So these are the various applications where we are using the fly ash. Okay, so that the rest of the fly ash is simply dumping on the open lands. If you will see this diagram, so in the first slide itself I presented, the picture is taken at Vijayawada NTPC, National Thermal Power Station, where the fly ash is dumping on the open lands and it is creating many environmental issues. So that if you can able to utilize 100% fly ash, so we can avoid these environmental problems. And it is the chemical composition of the fly ash and from various countries. So in any country, if you can see, the fly ash is having more silica content, alumina content as well as iron content. And coming to another industrial byproducts, ground granulated blast furnace slag, we can also call GGBFS, or simply we can call also slag. And it's like a glassy granular material ground into a fine powder. That's what we are calling it as a ground granulated blast furnace slag. It is the byproducts which is produced in the making of steel. So that these byproducts also we can utilize in the production of geopolymer concrete. Through that we can be able to reduce the carbon dioxide emissions, and as compared to the conventional concrete, utilization of GGBS in the production of geopolymer concrete will give more durability to the structures, and it will reduce the alkali silica reactions, and it will have more resistance towards sulfate attack and chloride attack also. And all around the world, GGBS is producing around 530 million tons. And this flowchart indicates from how the iron ore we can produce the steel and other residue like a GGBS. And this is the chemical composition of the GGBS, where silica content is more, alumina content is more, and also calcium content is more. And another byproduct, silica fume, and silica fume is produced from silicon metal or ferrosilicon alloy, and more advantage for this silica fume is it's 100 times smaller than average cement particles. So compared to the average cement particles, 100 times it's a finer material. So that by utilization of silica fume in the production of geopolymer concrete will have improved mechanical properties, because it will form a dense structure and it will bond the particles, and the bond strength of the concrete is good, so that it will improve the mechanical properties of the concrete, and permeability will be reduced, so that the chemical attack will be reduced, like inclusion of sulfate or chloride attacks will be reduced by utilization of silica fume, so that the structures will be more durable. And you can see the image of silica fume, how it will look, and also same image of the silica fume. So why, here I will go to back side once, why I am showing the same images also here. You can see the particle shape. The fly ash through same image we can be able to view the particle shapes are in spherical shapes in the fly ash. So interlocking is somewhat less as compared to the other binders. If you can see here GGBS, so the SEM image indicates the particles are irregular or angular in shape, so that interlocking and bonding properties will be good. So that many researchers are elevated that the combination of fly ash and GGBS are given better results, because of the fly ash particles, in between the fly ash particle the GGBS particles will settle and that the proper bonding is produced. And coming to another industrial byproducts is red mud. So it is from the bauxite residue, the production of alumina. So the red mud is the waste material, and the utilization of red mud will give more environmental benefits. So that the environmental challenges are there. So that red mud is one of the byproduct which we can use in the production of geopolymer concrete. And if you can see, for every ton of alumina produced, about 1 to 1.5 tons of red mud is generating. So compared to the production of alumina, the red mud wastage is more, and you can see here in the image how the red mud is releasing into the open land and environmental problems is creating. Also SEM image you can see, so where the different shapes of particles we can see. So that if you will use it in the construction, means it is used in the production of concrete, will give better properties. And the chemical composition, the silica content, alumina content, iron content and calcium content is also good in the red mud, so that we can use it as a pozzolanic material or a binding material in the production of geopolymer concrete. And coming to another industrial byproduct, rice as ash, we know it's an agricultural waste, where if you can use the industrial byproduct, rice as ash will give, is having high silica content, so it's around 85 to 90%, and the porous structure and lightweight, and we can able to use this rice as ash as an insulating material, and it's an environmentally material which we can use in the production of concrete. And the chemical composition, if you will see, silica content is more in the rice as ash. And another one is a metacolin. It is produced by the calcination of kaolin clay. It is also rich in silica, and it will give better mechanical and durability properties if you will use in the making of concrete. And if you can also see the SEM image of this metacolin. And another byproduct, sugarcane bagasse ash, where we know sugarcane bagasse ash is a residue which will left after extracting juice from sugarcane, and utilizing this sugarcane is also an environment friendly, and also it's having pozzolanic properties because of high silica content, and particle size and surface, specific surface area of this material is high. Particle size is less and specific surface area is high, so that we can utilize this. If you can utilize this sugarcane bagasse ash as produced in the production of concrete, will give a durable structure. And chemical composition of sugarcane bagasse ash, silica content is more, alumina content and iron content as well as calcium content is also more. So it is varies from country to country because of the paddy production. And overall this table, if you will see, so all the byproducts whatever we have seen, the comparison of the chemical composition of various materials. And so this slide presents the particle size and specific surface area of different industrial byproducts, where we can see the nanoparticles is having high specific surface area and also very less particle size. Particle size in x-axis it is mentioned in nanometers, and the preference where we can use these. So if you are going for nanoparticles in the production of concrete, it will be used in the functionally graded fiber cement, and the silica fume, up to silica fume we can use in the production of high performance concrete, and metacolin we can use in the production of conventional fiber based cement or concrete, and also similarly GGBS, fly ash, rice as ash, bagasse ash. So this diagram indicates, as compared to the Portland cement, all these byproducts specific surface area is as high and also particle sizes are less. so that if you will use these byproducts in the making of concrete as a partial replacement, it will give better dense structure, so that automatically strength and durability properties of the structure will be increased. So in the production of geopolymer concrete, two things we should take care while selecting the material. First is industrial byproducts. So up to this slide we have seen some of the industrial byproducts, their chemical composition and utilization of those products, how it will give the environment friendliness we have seen. And second material which we choose is activator solution, because the byproducts which we are choosing in the production of geopolymer concrete need to be activated by using the activator solution. So that's what the activator solution properties and the composition and ratios which we are choosing will plays a major role in attainment of the strength. So we are going to use either sodium based or potassium based activator solutions, and based upon the, so if you will see this fourth point, the compressive strength of geopolymer concrete depending upon the molar ratio of alkaline activator solution to the aluminosilicate source material, means the sodium hydroxide molarity which we are using here will plays a major role in attainment of the strength. And second point, if you can see, most of the researchers are suggested that the common ratio of alkaline solution ratio means sodium hydroxide to sodium silicate ratio is 1:2.5, means 1 part of sodium hydroxide if you are choosing and 2.5 parts of sodium silicate material we need to select. That is the common ratio proposed by many authors, but some of the researchers are went with 1:1, 1:1.5, 1:3 also they are seen because of the because of economic point of view, and also to check how the strengths are varying by varying the proportions of sodium silicate to sodium hydroxide. And also all these parameters, whatever the sodium silicate to sodium hydroxide ratio or molar ratio which we are choosing, will plays a major role to produce a stronger geopolymer matrix and also to produce extensive and silica alumina bonds, where if you are using high molar solution and also better alkaline solution will produce more extensive silica alumina bonds, a polymeric chain, so that it will help in the attainment of the strength. And we can see how the solutions will look like. So generally we will prefer sodium silicate in the liquid form, and the sodium silicate is highly producing by Kiran Global Solutions, so directly we can obtain from there. And sodium hydroxide will be available in the pellets from most of the places, so that according to the required molarities we can add the water and we can dilute the solution. And the preparation of activator solution, because it is also one of the major factor, and most of the researchers are used the molar ratio of sodium hydroxide is in between 8 to 16 molar, but some of the researchers have tried low molar based sodium hydroxide geopolymer concrete. And how the activator solution will be prepared, I will explain in the next slide. And this is the chemical and physical properties of sodium silicate. So Na2O mass percentage, SiO2 and water content, and what is the boiling point, all these factors we will see. And coming to the chemical and physical properties of sodium hydroxide, where purity is also one of the factor, where we will see the purity of the material which we are using, sodium hydroxide. Now coming to molarity, in sodium hydroxide molarity will plays a major role, as previous slide also we have discussed. So how if we need some molar, either 6 molar or 8 molar sodium hydroxide solution, how to prepare, you can see here. So the concentration of alkaline solution is the factor, and sodium hydroxide is having 40 gram per mole. So in the previous slide also it is presented. So So molar mass is 40 gram per mole. So that's what this is the standard value, and it will varies from the one solution to another solution. So to produce 12 molar solution, for example, so 1 liter of water plus 40 grams of NaOH will give 1 molar solution. Similarly, if you need 12 molar, so 40 grams we need to multiply with 12 because we need 12 molar, so that 480 grams of NaOH pellets we need to add for 1 liter of water. So in 1 liter of water we need to add 480 grams of sodium hydroxide pellets to produce 12 molar solution. So like that, which molar which we need, according to that we will add the sodium hydroxide pellets. But we need to take care while adding sodium hydroxide pellets, because it will produce the heat while adding it, so that better to check that and carefully we need to add. And this slide, if you can see, so water, sodium hydroxide and sodium silicate will give alkaline solution. So and you can see it will produce a heat up to 80 degrees Celsius, so that we need to store this solution in the cool place, and while preparing sodium hydroxide solution we need to take an additional care and use after 24 hours. So this is also major point. So today if you are planned to catch the samples, or today if you are planned to use geopolymer concrete in the construction, means 24 hours before we need to prepare this alkaline solution. So while preparing the alkaline solution, first we need to decide the molar ratio of sodium hydroxide, so that according to the molar we will add water, sodium hydroxide pellets to the water, and first we will produce sodium hydroxide solution according to the molar. Then we will go to sodium silicate, we will add according to the proportions which we need, either 1:1, 1:1.5, 1:2.5. According to this proportion we will add both the solution, sodium hydroxide and sodium silicate, to produce alkaline solution. And this slide presents the steps in the geopolymerization. So many researchers are highlighted the geopolymerization process, because how we are studied the hydration process in the conventional concrete. In the similar fashion, so geopolymerization we need to know, because based upon the geopolymerization process only strength will be attained to the concrete. So the first is source material. Like in the geopolymer we need to select the source material which should be rich in aluminosilicates. And second is alkaline activation. So the alkaline solutions which we are using, either sodium based or potassium based solutions, which will place a major role for the formation of geopolymeric chain. And this is an important step, dissolution stage. So this, you can see this point, the strong alkaline environment means the alkaline solution which we are using dissolves silica and alumina atoms from the raw material. The raw material which we are using are having strong alumina and silica, because we are using aluminosilicate materials as a byproducts. So these raw materials are free ions of silica and aluminate. So in the next slide also I will show how these will be free ions. Then next stage is polymerization. So the divided ions of silica and alumina will rearrange here, will form a bond. So it is like a bond by oxygen atoms. So you can see here, so a polymer chains are network of silica oxide, alumina oxide. So like this a chain bond will form. So this will crucial step for attaining the strength. And next is hardening and solidification. So in this stage a three-dimensional geopolymeric network will form, and which will be like forming a solid durable structure. So it is typically occurs at ambient temperatures and at heat temperatures also. So that these are the different steps which will be involved in the geopolymerization. So in the next slide I will explain in the more clear along with the chemical formulas, where the first two we are all know selection of source materials and alkaline activator. Remaining 3 steps are most important in the geopolymerization process. So if you will see dissolution stage, where I said already the aluminosilicate precursors like industrial byproducts react with alkaline solution and release silica and alumina monomers ions, and the below equations will form here. The alumina silica will form a alumina and silica monomers, and that is in the first stage. And in the next slide I will also present the video for more clarification. And in the second stage, agglomeration and reorganization, whatever the monomers which were divided from aluminosilicate material in the presence of alkaline solution will rearrange here and to form silica and alumina bonds, a polymeric chain. That's what we are calling it as a geopolymer. So a polymeric chain will form here. And in the next stage, so this chain geopolymeric process will form a 3-dimensional network. So that will plays a major role to produce better durable concrete. So these are the chemicals, these are the chemical reactions which will be produced at the time of this polycondensation or in the hardening stage. I request the participants to take 5 minutes break, and again we can join. Okay. I welcome back all the participants for this short break. So this slide presents you the geopolymerization process, where all know in the conventional Portland cement the calcium silicate hydrates will plays a major role in the strength attainment. In the similar way, in the geopolymer concrete, based upon the industrial byproduct that we are choosing, the either Nash gel or else Cash gel will produce. So Nash is sodium aluminosilicate hydrate, where if you are using more silica and alumina content in as a industrial byproducts, Cash gel will produce here. And similarly, if you are going to use more calcium and silica and alumina based materials, so Cash will produce. For example, more quantity of GGBS we are using in the production of geopolymer concrete, Cash will produce. And if you are using more quantity of either fly ash or Rice Cash or other alumina silica content base, so Nash gel will form. And the structure of polysilicate, if you will see in the geopolymer concrete, as I said, silica and alumina ratios will also play a major role in the formation of this chain network. So if silica and alumina ratios are 1, means the equal ratios if you are using, and you can see the polysilicate will form, this is silica and alumina bonds. And also if we are going to use SiAl ratio is 2, then polysilicate siloxo will form, and if it is Si/L ratio is 3, then silate and disiloxo will form, like that, based upon the silica and alumina ratios will also plays a major role here. And in the next slide I will present how to find this silica and alumina ratios. And this is the entire geopolymerization process as we discussed. So as aluminosilicate materials, in the dissolution process, silica and alumina species will divide, and again it will rearrange. Aluminosilicate agglomerats will rearrange here, and it will form based upon the SiAl ratios a 3D through polymerization, a 3D network will form and will produce a geopolymer concrete. And to understand this geopolymerization process clearly, so I am presenting a video here. If you can see this video, you can able to understand. Okay, I will move to next slide. There is a problem in playing the video. And the ternary diagram will represent the gel formations, you can see, based upon the industrial byproducts that we are choosing. So 100% fly ash based if you are using, then you can see this blue indication, Nash. If it is a silica rich and alumina rich, the Nash gels will form. If you are using 50% fly ash and 50% GGBS, means the silica and calcium content, silica, alumina and calcium rich materials if you are using, then you can see this green color. So either Cash or Nash will form based upon the materials which we are using, and 100% GGBS, the calcium, rich calcium based materials if you are using, then this yellow color indicates the cache, the gels will form here. So this one ternary diagram will indicate how the gels are producing through the industrial byproducts or combination of byproducts which we are using in the production of geopolymer concrete. And similarly, the several combinations, how the combination will produce the polymeric reaction will also be presented here. You can see this is also a ternary diagram, whether we are going to use silica rich materials or silica alumina based rich materials, or silica alumina and iron rich materials, or calcium and silica rich materials. Based upon that, you can see it may be a pozzolanic reaction or hydration reaction. And making of geopolymer concrete, you are already seen many material. In the next slide I will explain this. Okay. So these are the various factors while we are preparing mixed proportions in the production of geopolymer concrete. So these proportions also we need to look into. One is the type of alkaline solution we are choosing, and type of binder we are choosing, and source of binders. So whether it is a natural minerals or industrial byproducts, or solution to binder ratio we need to fix. So how water cement ratio we are fixing in the production of conventional concrete, in similar way in geopolymer concrete we need to look solution to binder ratio, means alkaline solution to the industrial byproduct ratios, and alkaline solution ratios, means sodium silicate to sodium hydroxide ratio we need to select, and molarity of enabled solution. As the previous slides we have seen, molarity will also plays a major role in the fresh properties, hardened properties, and in the long term properties of the geopolymer concrete, and type of curing condition. So which curing that we are choosing, either it is ambient curing, heat curing, or else it's a it may be some other type of curing that we are choosing here. And SiAl ratios, the next slide I will present this. So see how to find the SiAl ratios. As previous slide we have seen, in the applications SiAl ratios will plays a major role. If Si by Al ratio is more, then more durable geopolymer concrete we can able to produce. Then how to find this Si by Al ratio? So this slide you can see, consider a source material containing, for example, a source material which I am choosing. Source material means either industrial byproduct I am choosing. So 30% of SiO2 by mass is there in the chemical composition, 30% of silica is there, and 15% of alumina is there, means. So how to convert it into a, how to find the Si by Al ratio? You can see, convert these to moles. For example, molar mass of silica is 60 gram per mole, and molar mass of alumina is 1 or 2 grams per mole. Then how to find these moles of silica SiO2 is, so here you can see the silica content by mass is 30% in the primary binder we are choosing, that is 30 by the molar mass is 60 for silica, that is 30 by 60, 0.5 moles. Similarly, alumina, it is by 15 is the mass percentage of alumina, and molar mass is 1 or 2, the ratio is 0.147 moles. Then to calculate Si by Al ratio, Si molar mass is 0.5, moles is 0.5, alumina is 0.147, so that Si by Al ratio is 3.4. You can see here 3.4 indicates silica dominated geopolymer system, means silica content is more here, so that it is suitable for achieving high compressive strength within the optimal range. So that high silica content, if silica is dominating alumina, so that geopolymer will produce more mechanical and durability properties, enhanced properties of the geopolymer concrete. And in the literature, these are the various mixed proportion factors which are considered by the various authors in the different years. You can see different molars, different solution to binder ratios, and sodium silicate to sodium hydroxide ratios, and the binder content, the quantity of binder which we are choosing, this is for kg per meter cube, and also type of curing, and the aggregate density, aggregate quantity, heat curing or conventional curing. So different proportions which were chosen, and at these proportions how the strength is increasing, how the shrinkage properties are minimal, and how the modulus of elasticity of the concrete is increasing for initial days, means short term, at the same time for long term also. So that while we are choosing the geopolymer concrete, the factors consideration will also plays a major role in the attainment of short term and long term properties of the geopolymer concrete. And in the previous slide I said the production process, this entire flow chart indicates how the geopolymer concrete will be produced. Means, as I said, 24 hours before casting, the day of casting, 24 hours before the casting, the alkaline solution will be prepared, that is either sodium based or potassium based hydroxide, or sodium silicate or potassium silicate. So put together we need to prepare an alkaline solution based upon the factors that we are choosing. Then the aluminosilicate materials like either fly ash, kaolin, slag, red mud, whatever the industrial byproduct we are choosing. So on all these are mixed with conventional aggregates. The aggregates are common in either conventional geopolymer concrete. All we are mixing, and in the curing process, either steam curing, heat or oven curing or ambient curing, whatever the curing we are choosing. And finally outcome is in geopolymer concrete. This is the flow chart how the geopolymer concrete is produced. It's like a conventional concrete, only the difference is instead of cement we are using aluminosilicate binders like industrial byproducts, and also activator solution is a sodium based or a potassium based. Rest of the things are common. And if you will see a small model which will give how all the things which are going on in single slide I am presenting here, like material selection, what are the metals which were required for the production of geopolymer concrete, and the preparation of mixing and choosing a proper curing condition, and fixing the binder to activator solution ratio, and also other factors which we are choosing in the mixed proportion. This is the design of geopolymer concrete will be over. Then we are going to find the fresh properties. After that we are going to find the hardened properties, either it is a short term or a long term properties. So the images will indicate the production of geopolymer concrete, and this video will present the making process of geopolymer concrete, but due to technical issue videos are not playing. And curing for the geopolymer concrete. So as I mentioned, we can follow different curing methods, either it may be heat curing or oven curing, steam curing or ambient curing. So these are the curing conditions. So most of the researchers are elevating that oven curing is predominantly preferable at low temperature conditions. At the same time, if you are going to use fly ash is only the byproduct in the making of geopolymer concrete, or else conventional means ambient curing is enough. So that's what this slide is also present. Geopolymer concrete requires heat curing. Yes, in case we are using fly ash based geopolymer concrete, fly ash is only using as industrial byproduct. So then it required. Why it is required? Activation of fly ash particles. To activate the fly ash particles, so heat curing is required. To enhance the polymerization reaction, it requires heat, typically in between 40 degrees to 80 degrees Celsius, and also the reduction of setting time. So fly ash will take more time for for initial setting time. That's what, to reduce that we can go for heat curing, and also improves the mechanical properties. If you will go for oven curing or heat curing for fly ash based geopolymer concrete, will produce better mechanical properties. Until now we have seen how the geopolymer concrete will plays a major role in the reduction of environmental problems, and how it will be an alternative to the conventional concrete, and what is the mixing process we will use, and what is the geopolymerization process, and what are the reactions will takes place. These things we have seen. Now coming to the properties, say the fresh hardened properties, durability properties, we will see, and we can find as like a conventional concrete coats, whatever there, so similar kind of coats we can use here to find the fresh and hardened properties of the geopolymer concrete. Some images which will indicate how to find the initial and final setting time, workability, and compressive strength, splitting tensile strength and also flexural strength of the concrete. And I am presenting how the various authors are explaining about the properties or flowability, fresh properties of the geopolymer concrete. Here if you can see a fly ash replacement with GGBS. So the chart indicates if the fly ash is replaced with the GGBS, so 0%, if you can see the flow diameter is high, and also the time is taken very high for the flow. And if GGBS quantity is increasing 10%, 15% and 20%, the flow diameter is reduced, and also it is taking less time for the flowability. And the flow percentage, if you can see, and here 100% fly ash based, you can see flow by using natural sand and also lead smelter slag and also glass sand. So compared to all these things, the flow percentage is less if you will use glass sand, and flow percentage is good if you are using a natural sand for the geopolymer concrete. That is, this diagram indicates. Here NS is a natural sand, LSS, that representation is there here. And similar flow percentage, if you will consider the NaOH concentration, so molarity of NaOH will also plays a major role in the flow percentage. If molarity is 5, then you can see better flow percentage we can see, and the molarity is reduces, then you can see the concentration is high, the molarity of NaOH solution is high, then the flowability is reduced for the geopolymer concrete. Similarly, the molarity versus the initial and final setting time. So as less molarity of the NaOH solution, the initial setting time and final setting time are high. If molarity is increased from 7 to 15, you can see initial setting time is reduced and also final setting time of the concrete is also reduced. And coming to the compressive strength, based upon the material which you are choosing, for example, this is one of the mix symbol, R indicates 100% fly ash. If you will use only fly ash, you can see the compressive strength for 7 days and 28 days. And if you will replace fly ash with cement plus 10% cement plus steel fiber, you can see. So that's what, if you are going to increase this content, the strength properties were also increased. That presented by one of the author. Similarly, same author presented splitting tensile strength, how it is increased by replacing cement. So similarly, flexural strength. And another author is presented the compressive strength for 100% ordinary Portland cement is a control mix, and 100% GGBS if used, and 70% GGBS and 30% fly ash. Like in the various combinations, how the strength is varies is presented in this diagram. And finally he concluded that, and he has done the compressive strength for 7 days, 28 days and 90 days, and he presented that 75% GGBS, 15% fly ash and 10% silica fume is produced, better compressive strength. So that is presented by one of the author. And replacement of fly ash with GGBS, you can see this table indicates the fly ash is replaced with the GGBS 0%, 4%, 8% like that is increased up to 100%. And he concluded, you can see these values, 100% fly ash based is given better compressive strength for 7 days as well as 28 days as compared to other mixed proportions. Similarly with OPC, he also tried. So generally to avoid the OPC only geopolymer concrete we are using, but one of the author attempted, he replaced fly ash with ordinary Portland cement, and he according to these results he is saying 40% FC7 mix is given better compressive strength at 40% replacement of fly ash with OPC. Similarly, another attempt he has done replacing of GGBS with OPC. So similar he has done 12%, a 12% replacement of GG-base with OPC is given better compressive strength results, that is GC6 mix. So similarly, one author presented geopolymer concrete at different molars, 12 molar, 14 molar and 16 molar NaOH solution which is used, and also at different curing conditions like a woven curing and also sunlight curing. So he presented, compared to sunlight curing, woven curing is given better compressive strength results. And in another study, he presented the compressive strength of geopolymer concrete from 3 days, 7 days, 14, 28, 56 and 90 days, and he presented the different curing conditions also, like open air curing and 60 degrees woven curing, and he presented that compared to open air curing and 60 degrees woven curing is producing better compressive strength values that you can compare here, and also at different proportions, for example 90% fly ash, 10% silica fume and 12 molar solution. All these are 12 molar solutions are used in NaOH solution, and different proportions of fly ash and different combinations of fly ash and silica fume proportions were presented here. And he presented 50% fly ash and 50% silica fume based samples are so compared to these samples, so 70% fly ash and 30% silica fume based samples are given better compressive strength results compared to all other mixed proportions. And this is one of the study highlights the compressive strength values which are differentiating alkaline solution which are produced in the lab or alkaline solution which are purchased from outside. So means the alkaline solution is available commercially in the outside, like Kiran Global Solutions are producing alkaline solution, so this will present the alkaline solution which are produced in the lab for the production of geopolymer concrete, and these mixes will present alkaline solution which is produced which is purchased in the outside, commercially available, and production of geopolymer concrete. So if you can see these two graphs, it indicates at different proportions like 80% fly ash and 20% GGBS and 70% fly ash and 30% GGBS produced with conventional alkaline solution which is produced in the laboratory are given better strength values in ambient and also in the woven curing. And the effect of GGBS on the splitting tensile strength, you can see as GGBS quantity is increased from 0 to 60%, the compressive strength and splitting tensile strength values are increased. You can see this graph. So increasing in the GGBS content, most of the authors are said the same, increasing in the GGBS content, the strength properties are increased. So similarly, the predicted splitting tensile strength equation. So generally we know according to IS 5816, the splitting tensile strength, if you would like to calculate 0.7 root FCK, we have to use, which will be calculated from the compressive strength of the concrete. One attempt has made for geopolymer concrete, it is giving 0.77 root FCK. And for flexural strength, it is 0.98 root FCK. And this diagram indicates how to find the Young's modulus or modulus of elasticity of the geopolymer concrete through the compressometer. And by the replacement of fly ash with GGBS, how the modulus of elasticity values will be presented. The same mix means the 100% replacement of GGBS is produced better modulus of elasticity because of more dense structure. And also another attempt has made modulus of elasticity of geopolymer concrete mix with varying fly ash and wood ash. So wood ash is used as the replacement to fly ash here, and he produced 70% fly ash and 30% wood ash is giving better strength values for modulus of elasticity. And this is the equation which is proposed by one of the author. So we are all known the modulus of elasticity of the conventional concrete is 5000 root FCK, but here in the geopolymer concrete it is 3282 root FCK. So the value may be varies based upon the proportions that we are choosing for the production of geopolymer concrete. But from this we can understand, and many authors are said that the geopolymer concrete modulus of elasticity values are somewhat less as compared to the conventional concrete. So similar kind of study who has fine modulus of velocity of the geopolymer concrete. And from here we can see the durability properties of the geopolymer concrete, where we can go with porosity, softivity, RCPT, rapid chloride penetration test, acceleratory corrosion test, and different acid attack. So various codes which are also mentioned. So similar slide where the different characteristics of durability studies we can do. And coming to the softivity, the softivity is the transmission of water by capillary action is called softivity, and which we can determine the pore spaces through this particular method. So schematic diagram you can see how we need, and along with the code. So these two formulas we can use to find the cumulative water absorption and also to find the softivity of the concrete. And these are the softivity values of the geopolymer concrete. The water absorption is reduced once the GGBS quantity is increased from the increased in the geopolymer concrete, means replacement of fly ash with the GGBS is given better porosity, means better reduced porosity. And another durability property, rapid chloride penetration test. Here also we can observe once the mixes indicates increasing in the GGBS content. OPC is the conventional concrete, A1 indicates fly ash based concrete. Here A2 indicates replacement of fly ash with GGBS 10%, 20% like that. Increasing in the GGBS content we can see from high to very low RCPT value we can observe, charge passed. So that it indicates increasing in the GGBS content to the fly ash. The chloride penetration is less, so that more durable structures we can obtain. So another study also presented the similar way. And accelerated corrosion test. So a schematic diagram you can see. So reinforcement bar you can add to DC supply, and the surrounding bowl which we are using, the concrete specimen which we are using, which will be connected to the copper rod. And here we can use 6% NaCl solution. In that solution we can place this concrete sample along with the steel bar to find out the corrosion test of the concrete. So this is the total setup which we have made, and you can see the suffering of the sample under this acid, under this NaCl solution. And the results are indicating, you can see A1 to A7. So the critical corrosion current is reduced, and also the depassivation of crack time, how many days time you can see here. A7, where more GGBS content is there, is taking long time to appear the crack on the sample. So it indicates the geopolymer, in the geopolymer concrete, if you can replace GGBS, you can replace GGBS with fly ash, will give the better results in both strength and durability. And another factor, if you would like to find in the durability, means through acid attack we can find through these four factors: acid mass loss factor, strength loss factor, dimension loss factor. Through that we can able to find durability loss factor of the geopolymer concrete. By multiplying about 3 factors we can able to find the durability loss factor. And how the samples were suffered, geopolymer concrete samples were suffered at different exposure conditions, like through sulfuric acid and the chloride and also nitric acid at different molars, you can say at 2 molar and also 12 molar. So according to this author, at lower sodium hydroxide ratios the suffering is less. And similar, how the geopolymer concrete samples are changing the mass due to immersion in the various acid solutions. And carbonation test of the concrete, where all know carbonation is like a carbon dioxide infiltration into the concrete. So how the environmental carbon dioxide, in the environment carbon dioxide is infiltrating into the concrete sample. So this can be find through using phenolphthalein indicator. So if we can add 1% of phenolphthalein indicator which will spray on the concrete surface, so we can able to find this carbonation effect. So whatever the pink color indicates non-carbonated zone, and whatever other than pink color indicates the carbonated zone. So most of the authors are recommended geopolymer concrete is having more resistant towards this carbonation effect. And the compressive strength of the geopolymer concrete with the different proportions, which we can see here, like 2% nano silica additive or 2% micro silica additive, like that. So at different temperatures, the majority you can see at 300 degrees centigrade, the geopolymer concrete is produced better compressive strength values. At particularly geopolymer concrete with 2% micro silica additive, if you can add 2% micro silica content, so it is produced better results. And also the researchers who are working on geopolymer concrete, we should know the microstructural studies and how we can able to analyze the geopolymeric reaction, how we can find some of the predominant equations in the geopolymer concrete that can be done by through microstructural studies, where everyone knows this, the micro studies and macro studies. The studies which we will use through microscopic will give the micro studies, and macro studies are nothing but finding the mechanical properties through NDT or using UTM or compressive strengthening mission, which will elevate the mechanical and durability properties. And scaling is high, we can go for millimeters or 2 meters to find the macro properties. And coming to the micro properties, the scale is microscopic, means nano to micrometers, and will focus on internal structure and chemical composition of the sample. And the purpose is to analyze the mechanism affecting the properties, either strength is increasing or decreasing, can be analyzed through this. And these are some of the techniques which we will use in the microstructural studies, SEM, XRD, TEM, TGA, DTA and MIP. And applications, we all know in many applications these parameters will play a major role, particularly microstructural studies. So through microstructural studies we can able to find the hydration products like calcium silicate hydrate or calcium hydrate or ettringate formation, the same time pore structure and intrafacial transition zone, ITZ zone, we can able to analyze, and cracks and void, and chemical composition can also be analyzed through this microstructural studies. So these are the techniques which we will use, like SEM, XRD, EDS or EDAX or MIP and TGA. TGA is particularly for thermal studies, where increasing in the temperature the mass loss is there or not, we can able to check. And these are some of the microstructural studies which are highlighted by various authors, how the identification of silica to alumina ratio, and also Cash and Nash gel formations, and also unreacted fly ash particles or semi-reacted fly ash particles identification. So similarly at different proportions, 70% fly ash and 30% GGBS, how the microstructural studies are looking like. This is a semi-image scanning electron microscope image, and this is EDAX image, how the elemental percentage is identifying here, silica percentage, alumina percentage, sodium percentage. This is after geopolymerization. So similarly other studies were also highlighted at different sodium to sodium silicate to solution to binder ratio, how these gels will form. And so up to that, the various authors which were presented related to geopolymer concrete, fresh properties, mechanical durability and also microstructural studies. And here the slide will present the practical work which I have done in my research work. So field performance evaluation, many of the authors are restricting the geopolymer works up to laboratory only, but coming out from the laboratory, the practical usage is less, particularly in our country. So for example, if you will take Australia, they already implemented geopolymer concrete in most of the ready mix plants. They are producing geopolymer concrete also. In the coming years, definitely in India also will reach that stage the production of geopolymer concrete in the RMC plants. When the day will come, when the researchers will elevate more practical applications on the geopolymer concrete, then it will elevate. Now, quickly I will go through the field work which I have done. So, I have prepared one acceleratory pavement test track. So, these are the dimensions of the track. So, inner radius is 3.6 meter and outer radius is 3.6 meter and inner radius is 1.2 meter. The geopolymer track first earthwork is done, then after that I filled subgrade with 40 mm metal. After that compaction will be done with the 2-ton vibration roller. Then the total track is divided into 6 portions. So in each portion different mixed proportions were selected, like different combinations of fly ash GGBS. At the same time different solution to binder ratios were considered. And these are those 6 segments with different proportions of the solution geopolymer binders. And like this, the tracks are closed with the different samples along with one ordinary Portland cement sample. And at the time of casting the road, so different samples were prepared for the laboratory test and to compare the laboratory performance and also field performance of the geopolymer concrete. And a wheel arrangement is done because this should be a natural road where the wheel arrangement will also be done, and to carry the weights, the carriage is also placed here, and the motor is also fixed for increasing or reducing the speed of this rotation. And these are the various tests were performed on the track. So these images indicates what are the various tests that we performed. And these are the indications, like increasing in the GGBS content, the setting time is reduced, both initial and final setting time. The slump value is also reduced by increasing the GGBS content in the sample. And also if we will increase the solution to binder ratio, the slump value is increased. Similarly, the compressive strength, and we have done skid resistance test on APT because if it is a road, skid resistance is also important. The average scale that indicates here, you can see the scale, it will indicates 50 and high, that is a good resistance, so that geopolymer concrete all mixes are produced better results towards this skid resistance. And RCPT, as I said earlier, the RCPT values are good for the geopolymer concrete as compared to the conventional. And acceleratory corrosion test we have done, and it is also indicating increasing in the GGBS content in the geopolymer concrete is produced better results. And through XRD we analyze the formation of various elements here, quartz, calcite, hematite, so all the things which were indicated here. And you can see this point is an important point and indicates how the strength is developing. In addition, a strongly alkaline medium is essential to enhance the leaching of silica, alumina and calcium and other ions. So this leaching will play a major role in the strength attainment, but this leaching of these ions will be within the limit. So if it is crossing, the strength improvement will be reduces. That's what 0.45 solution to binder ratio is given better results. Further increasing in the alkaline media is reduces the compressive strength. So that's what this slide indicates. So these 3 mixes are used 0.45 solution to binder ratio is given better strength properties. Further increasing in binder to solution ratio from 0.45 to 0.5, the strength values are reduced. That's what, up to certain limit it will be okay, further the strength values are reduced. That's what this sentence is indicating. And these are the microstructural studies which were done for all the 6 mixes. And we have done non-destructive tests like a rebound hammer by selecting center point of the road and also interior corner, inside corner and also exterior corner of the road we have done, and almost we have seen. So this is the compressive strength values through rebound hammer. So this is the cube strength. And ultrasonic pulse velocity we have done, and it indicates the the strong matrix which we have observed here in all the geopolymer samples. And this is the core samples were collected to find the compressive strength, and we compared the strength obtained through cube test and also core sample strength and corrected strength. These are the equations which we will use to correct the core sample strength to the compressive strength of the cube, either it may be horizontal drilling course or vertical drilling course. And finally, from this lecture, it's clear that, or from the researchers who are elevated on geopolymer concrete, it's clear that replacing fly ash with GGBS will give better strength and durability and microstructural properties, where it plays a major role in the geopolymerization, and also using of little quantities of GGBS will avoid the woven curing. We can go for the sunlight curing or ambient curing. So that is another advantage for the geopolymer concrete. And also, while we are fixing the molar ratio, at the same time sodium silicate to sodium hydroxide ratio, we should follow the proper mix proportions which are suggested and highlighted by the various authors in the production of geopolymer concrete. So these are some of the conclusions. And the future directions of the geopolymer concrete. So for all the researchers should take care about the circular economy, because geopolymer concrete will place a major role in the development of circular economy, particularly in India. So government is saying the development of circular economy will place a major role in the economy development of the country. And also carbon neutrality, geopolymer concrete will place a major role in releasing the carbon dioxide which is produced to the cement production, and also the global adoption. So require a lot of practical applications, the practical exposure on the geopolymer concrete to adopt the geopolymer technology worldwide. And also future direction, so still there are gap to prepare the mixed proportions by using various industrial byproducts or else different kinds of solutions, and also to perform the long-term durability properties, seismic performance of the geopolymer concrete, and to investigate the geopolymer concrete behavior in the marine environment. At the same time, rheological properties of the geopolymer concrete, the flowability and all, how the geopolymer concrete will resist through the water pressure and all. These are some of the future directions where we can work on the geopolymer concrete. And on this work, so I received an appreciation award from NTPC New Delhi in January 2019. So this is that image, and these are the various papers which I published, particularly on the geopolymer concrete with various industrial byproducts like a red mud or fly ash GGBS paste, and also road network. So just now I have seen field performance which I have done, like that many things. Most of the papers are elsewhere in Springer. So similarly few more papers which were published in Ceramics International, Journal of Building Engineering, Cleaner Metal, these all are elsewhere in Springer. And I filed a patent which is granted, so it's an Australian patent. So these are the various references which I used to prepare this presentation. Okay, thank you all the participants for your patience listening to the presentation on the geopolymer concrete. I hope we are gone through all the areas of the geopolymer concrete. Now I am open for a doubt session, and before that I would like to conduct a test. I prepared some 20 bits based upon the presentation which I delivered to all the participants. So immediately after completion of this lecture, I will post the link in our group. Just click on the link and you can attempt this examination. Thank you. And any queries from the participants end, you can text in the chat box and I will reply here. So now I am open for question and answer session. Any participant want to raise any doubt? I am ready to clear. Any doubt from any participant? Please raise your doubt if you have any queries. Now session is open for doubts clarification, and also we will share a feedback link. Please provide your feedback on this lecture. So today is the first lecture, so 9 more lectures will be there which will be continued from tomorrow onwards. The same time, feedback link is posted. Kindly give your feedback on the presentation. Any messages from any participant regarding your doubts? And I will share this presentation also with all of you. Go through it and you can contact us at any time. So our details will be shared in the group. So you can contact and clarify the doubts on the geopolymer concrete. Thank you one and all. And as civil engineers, we need to adopt eco-friendly construction materials. So in future, please take this forward for the protection of the environment. Thank you one and all.